All right, so welcome to Lab 2% solution. I made a salt solution of unknown concentration, unknown to you that is, and you will be determining how much solute is in the solution. Okay, so if you obtain the lab either from Google Classroom or my website, this is the lab you should have. Ideally, in a perfect world, in a non-COVID world, in a COVID-free world, we would all be doing different solutions of different concentrations, but I don't have that much time, so we will all be doing solution A. Okay. Our purpose is to experimentally calculate the percent solution and the molarity of an unknown concentration of sodium chloride, and then you compare this with the accepted value. Okay, so the first step is to weigh a clean, dry evaporating dish. As you know, you put the lid down first so that you can add what you want to add right to it. So the weight is 66.90 grams. And I'll record that, pause. We will add exactly 10 milliliters of salt solution. And we'll weigh that. .81. So the mass of the solution we can get by subtraction. The volume of solution was 10.0 milliliters. Okay, at this point, if only there was an easy way to get rid of the liquid and leave the solid behind. Oh wait, that's where evaporation comes in. And that's where the lid comes in. So initially we don't want the lid so that the steam will just leave. But then once it starts to splatter, we need the lid on, otherwise we will lose quite a bit of salt to splattering. So we will pause this and meet you back here in about 10 minutes. Okay, so now it's boiling. So it's time to put the lid on, and you can see from the condensation on the lid how much slower it's going to take, or how much longer it's going to take, how much slower it's going to go. But with the lid like this, the evaporation is free to escape, and so we'll come back in another 10 minutes or so when it's totally dry. Okay, you can see now that it's completely dry, and so guess what we have to do? Take it off and let it cool. While it's cooling, we can pause it and you can talk with your neighbor about why we have to weigh cool glassware and not hot glassware. Okay, so it is now cool enough to weigh. Put your hand close, see if you can feel the radiant heat, then pick it up. Yep, cool enough to weigh. Put it on the scale. 68.22. Okay, so now if we zoom in, we can do the calculations. We subtract these two and get the mass of the solution. Subtract these two and get the mass of the solution. We know we used exactly 10 mils of solution. So if we subtract these two, we get the mass of solute residue. So 68.22 minus 66.90 is 1.32 grams of pause. All right, so here's the calculations. Percent solution is mass of solute over mass of solution. Pretty easy calculation. The mass of the solute is 1.32. The mass of the solution, 10.90. Divide those. 1.32 divided by 10.9, 12.1. The density, mass of solution over volume of solution. So the mass of solution, 10.9 divided by volumes of solution, 10.0 equals 1.09 grams per milliliter. We'll do the molarity later. So for our percent error, it's the error divided by the expected or accepted. So the error, the accepted value is 12.0. So 12.1 minus 12.0 divided by 12.0 equals 0.1 divided by 12. 0.1 divided by 12 equals 0.0083, which equals 0.83%. 0.83% error. Okay, so now the molarity calculation from the percent is kind of an advanced calculation. If it is on a test, it'll be a bonus. In fact, I may make a bonus question for you. So molarity is moles of solute per liters of solution. Percent is grams of solute per grams of solution. So we have to convert the grams to moles and the grams to liters. To convert grams of solution to liters, we use the density. And then to convert grams of solute to moles, we use the formula mass. So if we put the percent, 12 grams out of 100 grams, times the density, which is 1.09 grams per milliliter, times 1 over the formula mass, and the formula mass of NaCl is 58.5, and then times that by 1,000 to get milliliters to liters. So we have 1.12 times 1.09 times 1,000 equals 131 molar, which I think I messed up somewhere. So pause. Okay, so as you well know, your teacher is a knucklehead. So come back in here. We'll see our calculations. 12 divided by 100 times 1.09, and I forgot to divide it by 58.5, and then times it by 100. 1,000. So that's a much more reasonable molarity. 2.24 molar NaCl. Okay. Now, as far as the post-lab calculations, you can get the first two questions from the notes, and the rest you should be able to do. I will make number 6 and 7 on the back bonus questions. And then make sure you can do number 8 because it's a redoing of these calculations, which is sure to be on the test coming up, which will probably be on Thursday. And by virtue of the nature of this COVID crisis, it'll be a take-home test. So I will be sending it to you via the magic of the interweb on Thursday.
I can't stop it.